So I want to do yet another graphing problem here. I want to graph y equals minus 2 cos x. We're going to start off again with a curve that we know well, the cosine curve. The cosine curve is another sinusoidal curve. It's shaped like a sine curve. But instead of starting in the middle, the cosine curve starts at the top. So it's 1 at x equals 0, and it's pi over 2 at x equals, it's 0 at x equals pi over 2. Let me dot in these horizontal lines to make it easier for us to draw. It's negative 1 at x equals pi. It's 0 at 3 pi over 2, and we're back up to height 1 at 2 pi. We've completed one complete cycle. And let's draw this carefully. Now, as you're drawing this picture, exercise special caution here and here. You don't want it to look like the curve ever goes above height 1. You can see that if I continue this curve, it flattens out here and it starts going down again. So if you were to draw it like this, if you were to draw something like that, I know it's a little lumpy there, but let's ignore that for a second. That would still be wrong because you can see that if you continue this, it would go above height 1. We don't want that. We want something that will level out at height 1. And same thing here. If we continue this, which we could, it would start going down again. Don't make it look like if we continued it, it went above height 1. So be especially careful with that. So now I want to sketch y equals 2 cos x. Again, that's just a vertical stretch by a factor of 2. So instead of bottoming out at height 1, topping out at height 1, it tops out at height 2. And it bottoms out at height minus 2. We've just stretched every point vertically. So here, everything gets twice as far away from the x-axis as it was. I'll draw this in what I think is pink. But the original curve was y equals minus 2 cos x. So there's another transformation. There's a minus sign there. That's the same as taking minus 1 times 2 cos x. So I already have the 2 cos x right there. What does that minus 1 do? Well, we know it's a reflection over one of the axes. We know it's a vertical change. So if we move the points vertically, we have to be reflecting over the horizontal axis. So we're taking the whole picture and turning it upside down. So instead of starting out at the top, we start out at the bottom. That point stays where it is. This point moves up here. This point stays where it is. This point moves down here. And we will draw this. Again, if we start drawing like this, that's wrong because it looks like the curve goes below height minus 2, even if we don't draw it like that. It flattens out at height minus 2 at x equals 0. Same thing over here. And there we go. We've done 2 transformations, 1 stretch, and 1 flip over the horizontal axis.